Hello everyone. My name is Reet Patel, a student of Ramdev Baba University, and I'll be presenting an important topic of subject Introduction to Quantum Computing. And the topics are inner product, norms of vector, distance function, tensor product, and assembling system. Let's see now the learning objectives. Understand the inner product in vector space, learn how to compute norms of vector, explore the distance function, understand the concept of tensor product, and learn how this concept assemble into quantum systems. So now we will be concluding on to our first topic. That is, what are inner product? Inner product are nothing but the dot product of two vectors, or we can say projection of one vector on another, or angle between the vectors. Now see the example of inner product. Let us consider two variables u and v having some values. U is having 2, 3, 4 as values in vector space, and v has 1, 0, 5 in vector space. Now, what the formula for inner product would be u1 v1 plus u2 v2 plus u3 v3. So by calculating it, we are getting the value as 22. Now, we'll see why inner products are important. Because it helps to calculate angles between vectors. It also helps to compute length and distances between vectors. It also helps on basis for norms and distance functions. Now we'll see how we can understand the inner product geometrically. This is the formula for geometrical representation of inner product. This tells us that if angle is small, product is large. If angle is 90, the inner product would be 0. It means vectors are orthogonal. So, inner product connects algebra with geometric. So now we're gonna see our second topic, that is norm of vector. Norm of vector is nothing but the length or magnitude of vector. It tells us how big the vector is. For vector v, we have formula magnitude of v equals to under root v into v. Now let's see an example. For vector v, 3, 4. The norm of vector is magnitude of v is equals to under root 3 ka square plus 4 ka square. That is 5. Now let us see another example to express more. Let us consider v equals to 1, 2. So the norm of vector would be under root 1 ka square plus 2 ka square. That is ka square. That is 4 plus 1 root 5. This would be our norm of vector for vector 1, 2. And now I would like to tell you why norm matters. Because it helps in calculating errors in numerical methods, or it is used to define the distance between points. So now we'll be concluding to our third topic, that is distance function. Distance function is nothing but it tells us how far two vectors or points from each other. It also helps to compute quantum state and detect vectors. The general distance definition is d of u of v is equals to magnitude of u or v. So now let's see an example. The example is find the distance between vectors. We have considered two vectors u and v having values 1, 2 and 4, 6. Now, by substituting the values in the formula, we are getting the value as 5. So now let's take another example so we can conclude more about the distance function. Let us consider u equals to 2, 4 and v equals to 1, 1. So by putting the value formula in, we will be getting u minus v 2 minus 1 comma 4 minus 1. This is 1 comma 3. We would be getting 1 comma 3. So let's take the root of this 1 का square plus 3 का square equals to root 10. So the distance between two vectors would be root 10 of the values u and v vectors. So now we'll be seeing our next topic, that is tensor product. Tensor product is nothing but a way to combine two structures, two matrices, or two spaces in order to form a high dimensional structure. Simple meaning is it creates a matrix like structure for two vectors. As we can see here, u cross v, this is the structure for tensor product. For more understanding, we'll see an example as we know that we have a formula for 0 as 1 0. So let's see how tensor product works in this 0 tensor product 0. So it means 1 0 tensor product 1 0 means 1 1 0 0 1 0. So it will give us value 1 0 0 0. That is like this 1 0 0 0. This is the actual matrix form for 0 comma 0 0 gate. Now let us see our last topic, that is assembling the system. Assembling the system is nothing but assembling two finite elements to form one global system. Like inner product forms probability, amplitude, norms equals to valid quantum state, distance equals to state similarity, and tensor product equals to composite system. And the real life examples for assembling systems are it is used in quantum gates, norms and tensor product setups in the systems, and Qiskit simulates these concepts. Thank you.